This is Mr. Anderson for Kellogg Community College. This is Intermediate Algebra, Math 121, and this is the first section of Chapter 4, Inequalities and Applications. Today what we're going to do is we're going to take a look at some of the introduction to the inequality signs and how to use the interval notation. Now the first thing we're going to do is take a look at just some basic symbols. The symbol right here, which has the arrow pointing to the left, is known as the less than symbol. So this is pointing to the left. Easy way to remember it. Which way is it pointing? It's pointing to the left, so this is called less than. And this is pointing to the right. It's going to be called greater than. I know that we talked about less than and greater than earlier before, and usually we do that in relative to a number. We usually say the symbol is biting off the bigger number, and it would always be in the orientation to where the bigger number is. But when you just have the symbol by itself, you need to know how to call it. So this is called less than, this is called greater than. So if I had an example here where x is less than 4, on a number line here we would have, let's see, 4 I could put right there. Now the symbol that we're going to use is, instead of an open or a closed dot, we're going to use a curve. A curve represents whether, it represents that this is never going to get to 4. It'll get infinitely close to 4 but never quite touch it. So this will include all the values up to 4, but not including 4. So that would be x is less than 4. So if we have this symbol here where x is, let's see here, greater than, let's say 8. Sorry that my penmanship is so bad. So if x is greater than 8, again we have a number line here. We can put some numbers in, 7, 8, and 9, and here's our 8. And again we'll have a curve because we're not actually going to be landing exactly on the 8, and we're going to be going in this direction. And if you take a look, you'll notice that the arrow is going in the same way as this symbol, and that's true if the x is on the left-hand side. And it's good math grammar to actually have the x on the left-hand side, so this would be the greater than symbol. Now in previous classes you might have used an open circle for this, but the book uses a curve for these greater than or less than symbols. Now if we have a line underneath, this would actually be called less than, like its cousin upstairs there, but it'd be less than or equal to. That means I can have, exactly 4 if I wanted to. I could say x is less than or equal to 4, and the graph again would look like, there'd be a 4 right here, but instead of this being a curve, it could be at this model there a square bracket, and this square bracket is what the book uses to show that there is you can actually achieve that number itself. So this is going to be a square bracket at 4 and then a solid line going to the left there. This is going to be greater than or equal to, and that means it can be exactly 4, so I draw a line like this, and I'm going to say maybe x is greater than or equal to 8. So here I have my hard bracket there at 8, and this will go to the right then from that space. So this would start at 8 and include everything 8 and bigger. So there's greater than or equal to. Moving right along, we're going to also have some other symbols here. We're going to have the name of this is equal to. Oops, gotta choose the pen there. So this is going to be equal to, and equal to, if you have a graph where you're going to have x is equal to 4, just on a number line right there, you're just going to have a dot at 4. And if this is called not equal to, and if you have like x is not equal to 4, then x can be anything but 4. And if you have a number line with 4 on it, you'll have an open circle at the 4, and then everything else will be shaded in with a darker arrow. So to include that you're basically choosing every single number except 4. So that's equal to and not equal to. Alright, moving on to flipping symbols. Now we will flip a symbol when you multiply or divide by a negative. So anytime you multiply, anytime you multiply, and that's my crappy multiplication sign that should look like a star there, multiply or divide by a negative, you will get to flip the symbol. So in this case, if we're going to divide both sides by 5 to get the x all by itself, do not flip the symbol. X is going to be less than 2. In this case, you would think that you're actually multiplying or dividing by a negative, but you're actually looking at the number in the denominator. So in this case, nope, you do not flip the symbol. You will be dividing by a negative here, so you do flip the symbol. So x is going to be greater than 2. So you look in the denominator at the number that you're dividing, and there's a typo on this here. This should be actually be a positive 10. So if it's a positive 10 divided by a negative 5, you would flip the symbol. So x is going to be greater than negative 2. So you would flip the symbol if you're multiplying or dividing by a negative. Now there's another situation where we flip the symbol. Notice it says or there. We're going to divide both sides here by 5 to get the x all by itself. So x is going to be less than 2, or 2 is greater than x. But if I use the symmetric property, which says that I can flip the letters and symbols to its mirror opposite, you will see that I can now flip the symbol there. So you can flip the symbol either by multiplying or dividing by negative, or when you use the symmetric property, or to simplify that, when you flip the variable to the other side of the equation. And we've been doing this a lot, and you're probably wondering, well, I never did it before, but an equal sign flip looks like an equal sign. When you flip the variable to the other side, which is another word for the symmetric property. And this isn't an inverse operation. We're not actually subtracting x from both sides. We're just taking the x, moving it over here, the 2 moving it over here. The symbol flips it. Now watch, this is going to be the example of a double flip. I'm going to divide both sides by negative 5. So x is going to be greater than, notice the symbol flip there, negative 2. And then I'm going to move the x over here. And you'll notice that I read it backwards, x is greater than negative 2, or negative 2 is less than x. Now I flip the symbol around after I flip this x over here. So there's another example of the flip. Okay, moving on to the next piece. Let's go to page 2 here. We're going to learn about set builder notation, and we're going to learn about interval notation. There's going to be a little different between the two of these, set builder and interval notation. We're familiar with set builder notation because we've been using this with our x, and then we have some stipulation inside here. We can say like maybe x is less than 3, like so. But if we're going to use interval notation, the interval notation is going to be where we have to show, you know, where things are going. And if you want to do that with interval notation, you're going to have to see that if the highest number is going to be 3 and the lowest number is going to be infinity, the interval notation is going to have some soft parentheses here and here. And that's going to show you that when you have x is less than 3 on a number line, you're going to have basically a soft little curvy right there, and that's going to be 3, and this is going to go to negative infinity. So I should probably put my negative right there, and that will show me that my intervaltation goes from negative infinity to positive 3. And that will be the example of that set builder notation. Now if I have to go to a positive infinity, we'll show you that example down here. So given an example, x is less than negative 5. So the graph is going to look like this. I'm going to put my negative 5 here. You're going to have like negative 6, and you're going to have negative 4. Well, since this is less than, it's going to be a curve on that spot, and it's going to go down in that direction. So my set builder notation is going to be with my x, and x is going to be less than negative 5. And my interval notation, since this is going to negative infinity, I'm going to have negative infinity all the way to negative 5, and these are going to be soft parentheses. And the reason why this is a soft parentheses, we never get to negative infinity or positive infinity, and this is soft because we never ever get to the negative 5. Now let's go in the other direction. Let's go greater than. and we're going to have, let's see, -6 here, and this is going to be -5. The graph is going to have a soft parenthesis here. We're going to go into the right direction. All right, set builder notation, we're going to have x, and we're going to have, whoa, I didn't realize I changed that to a y. I'm sorry about that. Let's change that to a y. See, you never knew. And then y is greater than -6. All right, now we're going to do our interval notation. Now, it looks like our lowest part of that line is going to start at -6, but we're not going to touch it because it's greater than, not greater than or equal to. So you'll see that this is a curve, comma, and this goes to positive infinity. Notice I don't need to put a plus there. It's redundant. Putting a plus infinity is like putting, a +2. We don't usually put the plus with it. That would be sufficient. Okay, now for our last example, before I move this down here a little bit, it looks like I've got a z is less than or equal to -8. So I'm going to draw my line here, and let's see, -8, and this is going to be -9, and this is going to be -7. So now you'll notice that this is less than or equal to, so this is going to be a hard bracket there, and the line is going to go to -infinity because it's less than that. Set builder notation, being mindful that it is a z, and my z is going to be less than or equal to -8. All right, and the interval notation. Now watch this. It does go to -infinity, which is a soft parenthesis, always will be. But since we can actually connect the -8, look at my parenthesis. It is going to be a squared off parenthesis. And if I can't tell on your test whether it's, squared off or if it's soft, then I'm going to have to mark it wrong because I just don't know what you committed to. All right, let's do a couple more down here and see how many we can fit on the screen. We can fit like 3 more comfortably, and then I'll move the screen down again. All right, so x is greater than or equal to -10. So draw my line. I'm going to have my -10 right there, and here's like -11, here's -9, and you're wondering, why am I focusing so much on the negative numbers? It's just because we're probably not as familiar with them as we are the positives. All right, now this could be a colored in circle, but since this is a less than or greater than or equal to, I can actually make that a hard bracket and scroll to my right there. My set builder notation is going to be let me get my, x, and my x is greater than or equal to -10. All right, and then my interval notation is going to have a hard bracket at -10, comma, positive infinity, soft parenthesis, because we are going to go all the way there. Now you'll notice that there are some problems that we'll have to do before we get our graph. So just by solving for x, just like I've been doing in my previous chapters and classes there, just solve for x. I'm going to have 2x is going to be greater than or equal to 14, divide both sides by 2. Now do we flip the symbol? Since that's a +2, we do not flip the symbol, and that's x is greater than or equal to 7. The graph is going to look like 6, 7, and 8. Here's 7. It's going to be a hard bracket going to the right, and it's going to go to the right from the 7. Set builder notation. X is greater than or equal to 7. Oh, shoot! I forgot to put my x in my little line right there, so sorry about that. And my interval notation. I'm going to put a hard bracket there. I'm going to have my 7, and it's going to go to positive infinity, like so. So, sorry about the little typo right there. Alright, this one's going to be a little bit trickier, so what I'm going to do is try to simplify this. Now, since this is being divided by -5, I'm going to multiply both sides by -5. Now, when I multiply both sides by -5, I should remember my rule that if I multiply or divide by a negative, I have to flip the symbol. So this symbol would then not be less than, this symbol would be greater than 10. Then we subtract 3 from both sides. So -x is greater than 7. We're dividing by both sides by -1. And in doing so, x is going to be then flipping the symbol back, less than 7. And we've seen this a couple times before. Let's quickly do the graph here. Here's my 7. It's a curved line. It's not going to be a hard bracket. We're going to go to the left-hand side like this from our line. That's the solid line going in that direction. So our set builder notation is going to be x is less than 7. Don't forget your cool set parentheses, and then let's go to the interval notation. So it looks like we're going to go to negative infinity all the way up to 7, and since these are not less than, since this is a less than symbol, we're going to have a soft parenthesis. All right, 2 more problems to go. Let's take a look and see what we got here. And scrolling on down. All right, whoa, we got quite the equation here, as you can tell. Oh man, so I've left some room for me to work this. I'm going to take one side at a time here. I'm going to distribute this, and which is going to give me 8x minus 9x minus 6 minus 5. I'm going to keep working on this left-hand side here until I get this simplified down. Negative x, because 8 minus 9 is negative 1x minus 11. On the right-hand side, distribute the 3. This is going to be 3x plus 12 minus 2x. 3x minus 2x is just an x, and then we're going to have our plus 12. And we'll take a greater than symbol. I'm going to move my letters to the left. I mean, normally we wouldn't have any, real need to force that, but since I like my letters on the left, this is going to give me a negative 2. And I'm going to add my 11 to both sides here, do it in the same step. So I'm going to move this to the other side. This is going to be positive 23. If I haven't made a small mistake here, I believe everything is accurate. So then I'm going to take my negative 2x, divide both sides by negative 2. To get the x by itself, the symbol flips because we divided by a negative, and this is going to make negative 11.5 or negative 11.5. Because multiplying a positive or dividing positive from negative gives me a negative. So negative 11.5 or negative 11.5. The graph is going to look like this. If I have 11 and I have 12, shoot, I didn't realize that was negative, so I got to change this a little bit. This is going to be negative 12 over here. This is going to be negative 11. This is going to be negative 10. Sorry about that. Making little mistakes, but I'm catching them here. And of course, if you ever find a mistake, please email me and I'll put an annotation in this. Now, negative 11.5, is that going to be here, or is that going to be here, to the left or the right of the negative 11? It's going to be to the left of it, and we want less than that, so we're going to put a little curve right there and shade this in going this way. Make that a little bit more dark. The set builder notation is going to be my cool set parentheses there, and we're going to go x is less than 11.5 or negative 23 over 2. So there we go. Now the interval notation, we're going to go from negative infinity all the way up to negative 11.5, and we're never going to get there because this is a less than symbol and not a less than or equal to, so soft parentheses. Now our final homework problem of that section is to look at this domain. Now every square root has to be greater than or equal to 0. We cannot have anything, we can never have a square root that's less than 0 because if we do, it's an imaginary number. So what we're going to do is we're going to take this equation and set this 8 minus 5x greater than or equal to 0 and solve for x. We're going to subtract 8 from both sides. In doing so, we get negative 5x is greater than or equal to negative 8. Then we're going to divide both sides by negative 5. By dividing by a negative, the x is then going to flip the symbol. And negative 8/5 is the same as positive 1 3/5. So here we have a problem where x is less than or equal to negative 1 3/5. And then what we're going to do is graph that. This is going to be 0, this is going to be 1, and this is going to be 2. So where is 1 3/5? 1 3/5 is located between the 1 and the 2, and since this is less than or equal to, this will be a hard bracket, and that's a good estimation there of where that's supposed to be. And finally, the interval notation, because we can do the set builder notation just by adding an x and closing that off like so. We can do the interval notation by saying we're going to go from negative infinity to 1 3/5 but this time we need a hard bracket there and a soft bracket there. On a final note, you might have noticed that I've stayed away from the equations. Take a look near the top of the screen here. You see I've stayed away from equations where x is between two numbers. And the reason why I did that is because we saw a lot of examples in that from our previous worksheet where we had x when we looked at domain and range in chapter 2. And since we looked at a lot of these examples, I guess the only thing I would need to add is writing this in interval notation, and that would be going from -1 to 8. Looking at the way that the symbols are written, this is going to be soft because it is a less than, and this is a less than or equal to, so this will be the hard bracket. So as I point out in this worksheet, I didn't do any of these types of problems since we did an extensive amount of these in chapter 2, but you will be expected to see that and graph these, and that will be the resulting mark. And if I was to graph this on a number line, just to show you, at -1 you would have a curved line right there, and then all the way at 8 you'd have a hard bracket like so, and you'd kind of color this in the middle there. So there's a couple of homework problems like that, but just not too many. So thank you very much for watching the video. If you got more questions, please let me know or send me an email. Thank you.